Okay, this is lesson 3.7, part 1. We're going to split this up into two different lessons. The first part of lesson 3.7 is about absolute value equations. So take a couple seconds right now to write in the table of contents in your notebook, to update it for lesson 3.7, and then you can get your notes set up. Remember to put a page number on the note so that you can refer to it in your table of contents. Just a quick review. Don't write this in your notebook, just watch. A quick review about absolute values. Remember that the absolute value of any number is always going to be positive. So if I take the absolute value of 3, that will always be 3. But if a negative sign is sitting on the outside of the absolute value, that negative just gets tacked on in the end. So the absolute value of 3 with a negative out front is just negative 3. Here's another one. It says negative absolute value of negative 3. The absolute value of negative 3 is 3, and then I just tack the negative on the outside. Now continue to watch, don't write. Here are two examples with absolute values that now include variables. And a variable just means that what the value it represents can vary. So if you look at this first example, the absolute value of x equals 2, there are two different numbers that I can put in place of x that will make this equation true. And the two different numbers are 2. The absolute value of 2 is 2. That matches. And negative 2. The absolute value of negative 2 is also 2. So when working with absolute value equations where variables are involved, you're going to end up getting, in most cases, two answers. For this problem, the answer would be that x could be equal to positive 2 or negative 2. And a shorthand way to write that is just to write plus or minus 2. Now look at this next example. This one is just like the first one, except there's a 2 inside the absolute value. So everything inside of this absolute value could be equal to 2, but it also could be equal to negative 2. So the way you're going to solve an absolute value equation is to split it in two different cases. The first case, where 2x will equal positive 2, and the second case where 2x will equal negative 2. And then you solve both equations. Divide by 2, x could equal 1. Or if you divide this one by 2, x could equal negative 1. And how will you know if your answer is right? You can take the 1, put it back in the original problem. 2 times 1 is 2. Absolute value is 2. Then you can take this negative 1, put it in place of x. 2 times negative 1 is negative 2. Absolute value of negative 2, also 2. So here comes the first example you should write down. And this problem says the absolute value of x plus 2 equals 9. Now you're going to solve absolute value equations a lot like you'd solve regular equations, except for the absolute value part. So we're going to treat this absolute value of x just kind of like a big y. And my first objective is to get y by itself. So if I were given an equation that said y plus 2 equals 9, my first step would be subtract 2 on both sides to get rid of the 2. And what's left is 9 minus 2 is 7. I don't really have y here. What I really have is the absolute value of x. So I'm going to write the absolute value of x. And as we just saw in the previous example that you didn't write down, when I have the absolute value of x equal to 7, my answer could be that x equals positive 7, or that my answer equals negative 7. And the shorthand way to write it is plus or minus 7. All right, let's get another one. This one's different because I have a variable in the absolute value, but I also have a plus 3. Slightly different than the last problem. everything inside of the absolute value, x plus 3, could be equal to 7. But it also could be equal to negative 7. This is where you set up two cases. X plus 3 is 7. X plus 3 could be negative 7. Now, it's not always true that your answer will be plus or minus and then one number. Because if I solve this first equation and I subtract 3 from both sides, I get x equals 4. And I know that's true because if I put 4 in place of x, 4 plus 3 is 7. Absolute value of 7 is 7. Now, if I solve the second equation by subtracting 3, I don't get negative 4, but I get negative 7, and negative 3 makes negative 10. And I know that answer is true because if I take negative 10 and I put it in place of x in the original problem, negative 10 plus 3 is negative 7, and the absolute value of negative 7 is 7. So for problem 2, I get two answers. One is 4, one is negative 10. Now there's another problem that's similar to what I've shown you in the first two examples, but it turns out that it's not possible. So if I give you a problem like this, and you can call this problem warning. If I give you a problem like this, you would solve it by subtracting 9 from both sides. The 9's cancel. I'm left with the absolute value of x. 2 minus 9 is negative 7. Here's the issue. If I take the absolute value of x, will that ever equal a negative number? And the answer is no. You can never get the answer to an absolute value problem and have it be negative. It always has to be positive. So if you get something like this, there's no solution. It never works. Okay, here's problem 3. And in problem 3, we're adding just a little bit more complexity. Now I have 3 on the outside of an absolute value, which means 3 times. And when I'm solving an absolute value problem, what I'm really trying to do is always get the absolute value part by itself first. So to do that in this problem, I'm going to divide by 3. Dividing by 3 on the left-hand side will cancel out the 3's. What I do on one side, I have to do on the other side. What's left? Absolute value of x plus 2 equals 18 divided by 3 is 6. And now that I have the absolute value part all by itself, I'm going to make two cases. I'm going to split it. One case is where what's inside of the absolute value, x plus 2, is equal to positive 6. The other case is where what's inside the absolute value, x plus 2, is equal to negative 6. And now I just have two equations that I can solve. Subtract 2 from both sides in the first equation, I get x is equal to 4. Subtract 2 in the second equation, I get x is equal to negative 8. So now I've seen two examples where I've solved an absolute value problem and I get two different answers. Like I said, it's not always going to end up being plus or minus 4. And a common mistake in a problem like this is for students to finish the first part, get 4, and assume that the other one's going to be negative 4, when in fact in this problem it's negative 8. Okay, one more problem involving absolute values. And this one involves every combination of what you've seen so far. And like I said in the very first problem, we're going to treat this absolute value part kind of like one big variable y. And if I had a problem that said 3y plus 13 equals 19, you'd first try to get the 3y by itself by subtracting 13. And then you'd finish the problem by dividing by 3. So I'm going to attack this problem and let you watch and copy. And then when you come to class tomorrow, you can ask me questions. So to solve this problem, first step to get the absolute value part by itself is to subtract 13. What I do to one side, I do to the other side. 19 minus 13 is 6. What's left? 3 times the absolute value of x plus 2. We're trying to get the absolute value part by itself, so we get rid of the 3, which is being multiplied, by dividing by 3. What I do to one side, I do the other. 6 divided by 3 is 2, and I'm left with the absolute value of x plus 2. Now I have the absolute value part all by itself. The absolute value of x plus 2 equals 2 creates two cases, two different cases. One where what's inside of there, x plus 2 equals positive 2, and one where x plus 2 equals negative 2. I finished the problem. I subtract 2 on both sides on the left-hand equation, and I get x equals 0. I subtract 2 from both sides on the right-hand equation, and I get x equals negative 4. How do I know it's right? I go all the way back up to the beginning, and I put 0 in for x. 0 plus 2 is 2. Absolute value of 2 is 2. 2 times 3 is 6. 6 plus 13 is 19. That one works. The other solution was negative 4. I put negative 4 in place of x. Negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. 2 times 3 is 6. 6 plus 13 is 19. Both answers are correct. So you could get a head start on the assignment for tomorrow, which is 10 through 30 even. When you come to class, I will answer questions and help you get through that so you can finish it by the time you leave class.